So transformations of the reciprocal function. We have the reciprocal function on the right here. That's the original one, and that's the shape it makes right around the origin. Okay. If you remember, we talked about our function notation f at x was equal to, and we said the term a, which deals with vertical compressions and stretches, and then whatever the function is in brackets k, which deals with horizontal compressions, stretches, and essentially flips. X minus, we said c, which deals with translations of the function. And then finally, plus d. So these are the options that we're going to do. In this case, the function we're going to use is we're going to use a reciprocal function, which is 1 over x, when we have the original one up on our right here. Okay, there we go. So the first thing I'm going to do is I'm going to affect it with an a. Okay, and remember we said when a is greater than 1, it was going to stretch this function, right? So what we're going to look for is we're going to look at f at x, and then this function, I'm going to put the value of, let's say, 3 times 1 over x. So that's replacing our a. So we'll do this one at a time. So they're going to give us a function, but I'm going to delete it. And we're looking at 3 times 1 divided by, whoops, x. And if you notice this function here, we'll zoom out a little, it's been vertically stretched. It's been pulled upwards. Okay? With that same idea, I'm not sure what the next color is they're going to give us, but let's say f at x. And remember we said if a is a term less than 1, but between 0, it was going to be, we'll say 0.5, 1 over x. Okay? So we'll put that as our next function just to see what it's going to look like. So 0.5, 1 divided by x. And you see how the green one's been vertically compressed. It's been pushed downwards. So this is what it's doing. It's showing us how these numbers are affecting it.
So when it's compressed, it's getting closer?
Yeah, with a reciprocal function, it looks like it's getting closer and closer to the x-axis in this case. And we can zoom in a little if you like. Oh, that's the opposite. Okay. All right, so that's kind of what's happened so far. Also, we talked about, and I'm just going to show just an original one. Let's say f at x. And we'll use the number 5. So this is going to be stretched vertically quite a bit, but I'm going to make it a negative term. And 1 over x. Okay? Well, in this case, don't worry about that. Negative 5, 1 divide x. Okay? And you see what happened there? It's been flipped on the x-axis. It's been turning downwards, and it's stretched quite a bit because it's the value of 5. Okay? So those are vertical stretches.
So when it's less, it gets bigger, and when it's more, it gets smaller.
The idea is try to think of it like someone's pulling it from the top or pushing it down from the top. Okay? Because the size of it technically is not really changing. It's the points that are really changing. We'll get into that. We'll call
the space gets bigger.
Yes, the space between the x-axis. That's a good way to think of it. As the number gets larger, the space between the x-axis gets larger. And when the number gets smaller, the space between the x-axis gets smaller. So these are all vertical compressions and stretches. Let's do horizontal. Okay? If you notice horizontal, I know this isn't quite perfect, the writing, because we're out of time, but we'll do another one. Let's say f at x, but in this case is 1 over, and remember how we said, we'll do this one in blue, because we were doing k in blue before, f at x. Okay, we said that if k was greater than 1, it was a horizontal compression. So I'm going to turn these other ones off right now. Even though their values are still there, I just want to look at the original again. Okay, well, let's say this original one, if k is greater than 1, well, we'll say it's, whoops, 2x. Okay, that's a k value. It's right beside our x. Okay, see how here k is right beside our x? In this case, this 2 is right beside our x, so that's a k value. It's being multiplied by it. So let's do another function. And in this one, we're going to go 1 divided by 2x. Okay? Very similar to what we saw before. But in this case, technically what's happened is we've had a horizontal compression. It's been squished inwards. So think of like hands on the outside, push the blue one to where the orange one is now. Okay? So it's been horizontally compressed. Same idea. Let's do f at x. But in this case, we'll change that value. 1 over, and we said when it's between 1 and 0, we get a something like, let's say, 0.25 x. Okay, so let's put that function in here. In this case, we're going to get 1 divided by 0.25 x. And this has been horizontally stretched. So think of it like someone's taking the dark blue function and pulled it from the sides. And that's why it's getting farther and farther away from the y-axis. Okay? They look like they're almost the same types of thing as A. And like I said, they pretty much are, but they're just opposite of each other. Okay? So those are the horizontal stretches and compressions. And then finally, of course, we'll do a f at x. We'll make it a negative term. So let's just do the original, negative x. Okay? So let's put that function in here. We don't need derivative. 1 divided by negative x. And you see how it's flipped? And the flip is very similar to the other flip. But in this one, it's supposed to be like it's flipped on the y-axis instead of the x-axis. So that's how these numbers have affected the reciprocal function so far. Okay? And then I'll turn them off just to quickly show you the last two. We're going to do a C movement. Okay? So f at x is equal to 1 over x. And what we're going to do is just add 3 to it. Okay? So we'll just do one of each for this one. 1 divided by x plus 3. And do you see how the whole function, I know it's a bit hard to see, we'll move it, has been shifted upwards 3. Okay? The same idea is if it were a negative, 1 divided by x minus 2, the whole function will have been shifted down 2. Okay? I just want to finish up this one last thing. Okay?
So it's like the C and D thing.
It's just movements. This is the C and D. And then finally, the last one we're talking about is, that was a D. Okay? This was a movement of D. C would look like this. Oh, that's a bad color. F at x is equal to 1 over x plus 2. So it's below. Okay? And if you notice what will happen there, hopefully we can do it, 1 divided by x plus 2. And if you notice, see, they've even moved the line in the middle. It's all shifted to the left. And remember we talked about it shifts everything to the left if it's positive. And if it is negative, it shifts everything to the right. It's counterintuitive, this one. Okay?